All right, good morning. Time got away from me. I was like playing with code, and suddenly it was 9:58. Um, yeah, I think it's the same setup as usual. Good morning. Yeah, hope everybody's doing well. Um, hope everybody voted. So, um, I grew up East Coast and lived East Coast most of my life, and voting meant, going and standing in line sometimes for hours. And I moved out here and, discovered all the voting is done by mail. That is so cool. So, hopefully people already voted a while ago and don't have to go stand in line. But anyway, so, questions. And yeah, you do have to plug in your headphones to hear me. All right, let's run through ODP 414. Let's talk about the next ODP, and then let's talk about your next programming assignment, which I just posted a few minutes ago. And then we'll go from there. So let's start with 414. And then we'll talk about 418. So let me show you what would work for 414. So 414, we were interleaving those two strings, and we looked at some pseudocode for that. And my implementation is pretty much straight from that pseudocode. So two incoming strings, S1, S2, and output string out, initialize a pointer for where you're going to store things, an index, and then go through all the characters in either string and just assign the next character from S1 to the output, assign the next character from S2 to the output. I used a post increment here, so it's like adding outlook equals outlook plus 1 after the assignment. And then when you finish the whole loop, outlook should still be the next spot in the output string, and so you can put your null terminator right there. So that comes straight out of the pseudocode. So let's look at 418. And so here we're also creating an output string, but we're building it by shifting the contents of an input string. We're shifting down one position. So if your input is something like HELLO, then your output should be ELLOH. And this is slightly more complex than interleaving two strings, only because you have to do two things instead of one. Interleaving the strings, we just kind of went through and we just pull from the first, pull from the second, pull from the first, pull from the second, and keep sticking them on the output. And then when we're done, just put in that null terminator. So how could we do this? Well, same idea. Set an output location. And this time, let's go for I equals 1, I less than string length of in. Right, so we'll start with the second character, and we'll say out bracket, output location equals in bracket I. Right, and that will definitely copy the ELLO, and it will leave output location sitting right here. And then you just assign that to the first character in your string. And then throw on the null terminator at the end. So that works great, except when we do this, Actually, when we do this, we can get into trouble. Nope, this should work fine. I was thinking there might be an edge case if your string is empty. But think about edge cases, right? Suppose your input string is just totally empty. So string length will be 0. Will this for loop do anything? I will start from 1 and it will run as long as 1 is less than 0. This for loop won't ever do anything. And so output bracket output location plus plus, right, will be set equal to in bracket 0, which will be a null terminator. And then we're going to store something in output location 1, which you probably don't want to do, but I don't think it's going to blow up the assessment. But you could do an explicit test case up here. If the string length of in is 0, then just set your output string to be an empty string. So set character 0 of your output string to be the null terminator and return. But I think this will work even if the string is totally empty. And run some other test cases. So suppose your input is equal to just the single string A. So character 0 is A, in 1 is null terminator, string length of in is 1. Alright, so play computer, pretend you're the computer. We're going to set output location equal to 0. We're going to say for I equals 1, I is less than the string length. Well, the string length is 1, so again this for loop never fires. And all we're going to do is we're going to set out bracket output location 0, which gets incremented, is equal to input 0, which is an A, and then out bracket output location is 1 will be the null terminator. And that looks correct too, because if you just have the string A and you shift it one spot and take the leftmost character and put it on the right, you get back the original string. So something like that should get you good assessment. Alright, so yeah, shoot me a note this morning if you're having trouble after trying something like this, and I can see what's going on. There's other ways to do this. You could copy the input to the output and then try to shift everything down in place and then try to take that leftmost character and put it on the right. Those start to get into troubles with edge cases sometimes, and you got to remember, if your string is empty, you never want to access character 1 of that string. Right? If it's empty, then that array has at least one position, which will have the null terminator, but it's possible that that entire array is only one character. So just think about those. All right, similar note. Let's talk about string comparisons. So you didn't need to do a string comparison for homework 6. You could just compare individual characters. But suppose you want to actually compare two strings to see if they're equal. So here's some test code. So I've got a temporary character array called buffer. I'm going to prompt the user, let them input a string, and then I'm going to say if buffer is equal to hello followed by the new line, then I'll print out good, otherwise I'll print out bad. And our hope here is that, you know, if the person types in hello and hits enter, then this is exactly what buffer would equal, and we would get the message good. But that doesn't happen, right? Even though I say hello new line, it tells me that's bad. and we can print out the contents of buffer. Right, and I'll print it out inside angle brackets so we can see exactly where that string begins and ends. And if I say hello and I hit an enter, this string is clearly entered to equal to HELLO followed by a new line. But my comparison doesn't seem to notice that. Okay, so you cannot use equal equal when comparing strings. Okay, that's a general rule. When we get into Java, we're going to extend that and say don't use equal equal to compare objects. Okay, remember a string is really an address. If I were to print out the contents of buffer as a %d, I would see the address in memory where this, character array is stored. If I were to print out HELLO as a %d, we would see an address where that string was stored. And if those addresses are different, then this equal sign will fail. Yeah, we use Java and Spring. That's the whole Spring course, 223, Advanced Data Structures in Java. So the correct way to compare strings in C is to use string compare. It's a function just like string length and so on. And string compare takes two strings, it returns an integer. Okay, and this is kind of like scanf. You got to be really careful about what you do with this integer. If the two strings are equal, it will return 0. If they're not equal, it will return non-zero. Alright, so returns an integer less than, equal to, or greater than 0 if S1 is less than, matches, or greater than S2. So it basically compares these things alphabetically, and if one is less than the other, comes before the other or after, then the return from string comp will be negative or positive. Not necessarily -1 or +1. But if you want to know if two strings are the same, you got to check to see if string compare returns 0. Okay, that's the only way that you know that your strings are the same. So here I can say if string compare with hello new line returns a 0, then go ahead and print out good. And so if I say hello and I hit an enter, that works great. And if I say hello to, that's not the same. And if I say hello without the uppercase H in the beginning, that's not the same. Alright, so if you want to compare strings, string compare is your friend. And here's an illustration of where this fails to work, right? If I set if I just make an if statement, if hello is equal to hello, print out good, else print out bad. Right? And that says good. Right? I mean, it looks like this is working correctly. So let's copy hello into our buffer. And let's see if quote hello is equal to that string that we just copied into our buffer. And I need string.h, but that's okay. But they're not equal, right? They're not equal because even though the contents of this buffer is HELLO new line, right, and the contents of this string is HELLO new line, they are different locations in memory. right? And that's what equals equal is checking, is do these have the same value? Well, the value of this string is its location in memory. So those are definitely different. On the other hand, here I've got two completely separate variables, b1 and b2. I set them both equal to hello. I check to see if they're equal. Guess what? Those are equal. And that might seem weird because they're separate variables, and the only thing they have in common is I've set them equal to the same string, and I just told you this isn't comparing the contents of the string, it's comparing the address. Well, when this code is compiled, the compiler creates, information saying somewhere in memory you should have a string containing HELLO new line. And whatever address that's stored at, that's what it gives as the value of B1. And when it gets to this next line, since it's already got a string containing HELLO new line, it goes ahead and it sets B2 equal to that also. And so B1 and B2 are the same location in memory. So I can try to change the first character of my string B1. And there's a good old segfault. If I was allowed to make this change, that would automatically change the first character of B2. Because they're pointing at the same location in memory. But since the compiler set this string up for me and put it somewhere in memory so that I could refer to it as the value of B1 and B2, it's a write-protected area of memory. So strings can be weird, right? If you go back to thinking about what's going on at the hardware level, if you think about a string as, not just a happy string inside quotation marks, but think of it as a collection of bytes stored in memory, and the actual variable itself referring to the address of that first character, right? Then a lot of these things are less mysterious. Now when we're mixing strings together or things like that, yeah, it's just an array of characters, it's a happy string in quotes, that's fine. But be able to go back down to this level and think about what's going on in the memory of the machine. And this is all build up to 222 in winter quarter, when that's all we're doing is manipulating bare memory with C code. So that's what data structures are all about. All right, so that's some business of strings. And like I say, if you really just want to compare, an individual character, right, you can say something like, if buffer bracket 0 equals, quote, H, right, that's totally legal because technically it's an integer, it's a short integer. This is also an integer, it's a character, but it's a short integer. And you can compare two integers to each other, right? That's what the equal does. So for characters, works great. For strings, this thing is actually an address in memory, and double quote H would be another address in memory. All right, questions on that? All right, let's take a look at your next homework. So I posted this on Canvas just a little while ago. This is due a week from Friday. So you have almost 2 weeks for it. Yeah, let me move it over here. All right, so homework 7, you're going to implement a calendar program. And you're going to do this in Bash, and it's going to be a graphical program. It's going to involve making a GUI to interact with your program. And this is a group project, so you get to work in groups of up to 4 people if you like. If you really want to work alone, you can work alone. But I recommend doing this in a group because we need group work in our education. Usually at university level, there's a lot of group work in courses. And working in a group is not just, you do this and I'll do that. There's a lot to do with, coordination. There's a lot of sort of so-called soft skills in communication and planning and conflict resolution and things like that. You can do this as a group project, right? So you're all Zoom savvy at this point, whether you wanted to be or not. And you can collaborate on Zoom, right? Or whatever your favorite method is. But you should be able to screen share and do all kinds of things like that. So you want to spend part of this figuring out who you want to work with and then how you're going to do this as a team. All right, so overview. So you're writing a Bash script, which basically implements a calendar program. And this is the counterpose to homework 6. Okay, I'm giving you a lot of flexibility in how you implement this. I'm not giving you a big long list of you have to split it into these functions and your file has to be called this, right? You really get to set this up as your own design, your own creation, okay, between you and the people in your group. And yeah, you get to pick the people you want to work with. I'm not going to assign groups. And if you want to be in a group but you don't know anybody to work with, send me a note and let me know. And if there's, enough people like that, then I can go ahead and put people into random groups. But, go ahead and get to know people in the class. If you want to work, so groups are 4 people or fewer. If you want to work with somebody from a different section, that's okay. Part of the project is a presentation by at least one member in the group, so you need to coordinate. If you want to work with someone in the class that meets at 11, you got to figure out when you're going to present and so on and so forth. But yeah, groups of 4 from this class or section B. All right, so what does your calendar program do? It basically it lets you do at least 3 things. Make an appointment on a given date. Okay, so such and such is my due date for homework 7, or this is my cat's facial or whatever. Lets you create appointments on given dates. Lets you delete appointments that you've created, and lets you look at upcoming appointments. Okay, and that's all I'm saying about those. So I don't care in what way you get the information from a user to make an appointment, or how you specify an appointment you want to delete, or how you specify which upcoming appointments you want to look at, or how you display those, or how you stylize them. Totally up to you. Okay, you've got a lot of creative liberty here. So it's got to use a command called dialog, which we're going to run through later on today. But it's a simple Unix tool for creating, sort of 80s style graphical interfaces. But it's nice because it will work on the Linux server, and you don't have to open up an X channel to an X tunnel to send graphics information through. It just runs using VT100 escape codes. If you don't know what that means, don't worry about it. But the punchline is you can run this on the Linux server connected through PuTTY or SSH or whatever your favorite client is, and it will pop up things that look like GUIs on your terminal. And it does allow for mouse input. At least when I run it under Linux, it does. I've had some people in Windows who say their mouse doesn't work, but for me it seems to work. So we'll play with this in a few minutes. All right, so it's got to use dialog. It's got to be implemented as a GUI. Okay, it's got to at least do these three things: let you make an appointment, delete an appointment, and look at upcoming appointments. I'd like you to keep command line interactions to a minimum. So it's possible, you could say, I want to make an appointment, and then in your terminal session, it could say, type in a description of the appointment, and you type that in and hit enter, and it uses a read command or something like that. I'd like you to minimize that. I want it to be as GUI based as possible. Okay, so that the person doesn't actually know that they're sitting on top of a Unix machine. Your calendar should be preserved from run to run of your program. So you want to save all the calendar information in a file. All right. And you can design the file structure however you like. One real simple way to do this would be to just make a plain text file, one line per appointment. And each line could have a date in some predefined format, followed by a delimiter like a pipe, a time followed by a delimiter, and then a description of the appointment followed by a new line or some magic marker, Control A, something, right? Throw that all on one line. That works perfectly well. But you can choose how you want to store this information. But the goal is, if I run your program and I make some appointments and then I exit your program and then I run it again, those appointments should still be there. Okay, so you're going to use files to save this information. And then, obviously, if you delete an appointment, it should delete that line from the file or mark it as deleted or something like that. So on the Linux server, under the /temp directory, there's a subdirectory called calendars. It's readable, writable by the world. Feel free to make yourself a directory in there and use that for your storage of files. Okay, that means you don't have to open up an area in your home directory tree, but you can create a directory in there and people in your group can access it and share it and so on and so forth. So that's available. All right. In addition to creating, deleting, and looking at appointments, you have to implement 3 additional features. Okay? And you get to choose those. And so here's some ideas for additional features. Being able to edit an appointment after you've made it. Being able to go in and change, the date of it or the description of it or something like that. Being able to add a time to appointments, okay, instead of just a date. Adding an end time as well as a start time. Checking when you make an appointment or change an appointment that doesn't conflict with an already existing appointment, or noting that it conflicts with an appointment. Viewing all appointments on a given date or on a given date range, as opposed to just all the upcoming appointments. You could add a reminder feature so that when you first run the program, it tells you about any appointments coming up that day or in the next few hours or something like that. You could add an alarm feature. So cron does run on the server. You could create a cron job that that lets you, that will send you an alert, for example, or an email on the server or something when you have an appointment coming up. If you want to get really, really fancy, you could try to import or export an iCal file, for example, to interact with other programs. This should not be harder than the other programs, actually. So you do need to figure out the dialog command, okay? But once you figure that out, doing these 3 things is basically file manipulation, right? So if the person wants to make an appointment, ask them what date the appointment's for, ask them for a description, and just echo those and append it to the bottom of a file. If you want to delete an appointment, ask for the date and show them a list of appointments on that date, and ask them which appointment they want to delete. They'll say appointment 5, and go ahead and do that. And this dialog command will do all the heavy lifting for you. Okay? It will display menus, it will display lists, it will create edit boxes, it will display information fields, it will ask people to input a line of text. All of that is provided for you. Okay, you just have to get good at using it. And the optional features, I would say adding a time and adding an end time, those are pretty straightforward. It's really just an additional dialogue that says, when does the appointment start and when does it end, or how long is it. right? So those are pretty straightforward. And then viewing all the appointments on a given date, that should be pretty straightforward. There's a calendar dialog. You can get a date, and then basically just go through your file, look for anything with that date, and display the corresponding appointment. And let's see, so is this something we could write without a GUI and then add one in, or does the GUI use like other coding? You could write the mechanics of this without a GUI and then put the GUI on top. But you probably want to start off by thinking about it in terms of a GUI, just to kind of make sure that the code you would implement would work well. But the GUI is really simple in its interface, and we'll look at that next, and we'll see how you feed things into that and how you get things out of it. And I think you'll probably end up deciding to just start working with the GUI from the beginning. And it's more fun having graphical stuff anyway. But we'll look at that shortly. All right, so groups of up to 4 people. I would like an email on the Linux server by noon this Friday telling me the full name of all people in your group. Okay. If you want to work alone, you can send me an email saying you're going to work alone. If I don't get an email from you, I'll just assume you're working alone. If after a day or two you don't think you can find a group to work with, right, send me a note, either regular email or Linux server. And if I've gotten other people in a similar situation, right, I'll put people together. 4 people max in a group. Project is due 8 a.m. a week from Friday, so that's the 13th November, not 13th now. And I need one person from the group to upload to a Git repo named Homework 7 as usual. All right, if multiple people upload, I'll just take whichever one I find first. And then there's going to be demonstrations in class of your program, because I'm not going to necessarily know how to use your calendar tool. So next week we'll talk about specifics for when this is going to happen, but I need at least one person from each group to demonstrate the program to the class. All right. Grading to get any points, it's got to be submitted by the deadline through Git. It's got to run on Linux. It's got to use dialog, and it's got to be presented to the class. So those are mandatory to get points. Okay. Assuming you're doing those, points get awarded as follows: 20 points for each of the 3 required assignment functions, 10 points for being able to save the information from run to run, and then 10 points for each of the 3 additional features. So pretty straightforward rubric. All right, and yeah, this definitely is a fun project. If you started early, figure out dialogue up front so that it's not a constant thorn in your side, and work with people, have some fun time to think creatively. What do we want to add to this? What would be the ideal? What are the wacky things we could do in here? And then split it out into pieces, come up with a timeline, plan on how you're going to put the pieces together, hopefully not Thursday night at 10 p.m., right? Because things don't always go together nicely. But you've got, it's Tuesday, you've got, 10 or 11 days to work on this. If you started early, it should be pretty doable. And, ideally you can get through a working version of it in a few days, and then spend some time just adding on some polish, debugging it, things like that. All right, yeah, and presentations are lower key now because it's just screen share and microphone, so that can be cool. All right, so other questions about this? All right, so let's talk about this dialog command. So dialog is a command that's available on the Linux server. You can install it on your own system, sudo apt install dialog, if you want to run it on your own Linux setup. The manual pages feel kind of disorganized to me, but that's just me. But basically, here's the basic types of things that you can do with this. And the ones that might be interesting to you, you can make a pop-up calendar, you can do checklists, or radio lists where people can choose, from a list of options. You can create menus. An edit box will display the contents of a file and let the person change it. A message box will just pop up a quick message with an OK button. A text box will let you display more information with some buttons on the bottom and so on. Let me show you a few of the basic dialogues we can create with this, and then we'll talk about capturing output, and then I'll mention some of the embellishments we can make on this. But you really need to kind of do a once-over on the manual page and at least notice the different sections that are available in there. There's also some good summaries of this online outside. But for example, we can add extra buttons, we can change the label on the exit button, and so on and so forth. Alright, so what can we do with this? Dialog message box. So most switches in Unix commands, if they're more than a single letter, you put a dash dash in front. Okay, the reason being, if you put a single dash, that's a shortcut for saying dash M, dash S, dash G, dash B, dash O, dash X. So dialog and most other commands, dash dash in front of option names with a long name. So this is saying I want to create a message box. And you can put text field, right? So this is where the text goes. And then 00 specifies the height and the width. Okay, and 00 just means pick a height and a width that are appropriate for this. And when I run this, it creates a dialog box. And so whatever I put in that argument, and I put it in quotes to make it one argument, that appears here, and there's an OK button. So I can click on that OK button, and that exits my dialog, or I can hit the Enter key, or I can hit the space bar. You can't see the difference, but it's different. And that's just a way to sort of show some information, like the world is ending, and you can say OK, and it'll go on, right? And this command can go inside a bash script, right? And so your whole program is probably going to be, a series of calls to the dialog command. All right. Yes, so you can alter what the box OK says. So there's a dash dash OK dash label. Right, so you can change that. And there's tons of options, right? Okay, so that's a basic message box. If you want more information, you can do dialog, and I can throw titles on here. And most of these things take titles. So dialog dash title, and I can say dash dash info box. And I can say this is a test, and put in my dimensions for my box, and there's an info box with no interaction needed from the user. It just displays something. But if I did that, and I put a sleep after it, then that would hang out on the screen for 5 seconds, and then it would go on with whatever comes next in my script. You can also specify dimensions on these things. So if I say, nope, hold on. If I say 200, 0, that first 200, that's the height of my dialog. And the 0 says make it as wide as necessary. If I specify a width, right, it makes the height whatever is necessary. And I can specify both. Alright, so 100 by 75. I think that's in characters. So these are kind of ridiculous. I could do 10. Or let's do 10 and 40. So that's 10 characters high, 40 characters across. And you know, if you have a really tiny font size, then yeah, you get really tiny dialog boxes. And if you have a really big font size, then you get really big boxes. Can you do percentages for what? For dimensions? I don't think so directly, but you can figure those out, right? So you can figure out how big your terminal is and then do some calculations and feed those arguments. And remember, we're in bash, right? So so you know, I can do something like, you know, height equals 30 and width equals 20, and then I can do my dialog and I can say height width, right, and get my dialog like that. So bash makes life better. That's a t-shirt. All right. And so, you know, we can say dialog info box. And, you know, instead of typing in a string, I could say something like cow say hello. All right, and there's a info box with a talking cow on it. All right, what else? There's a yes/no box. And almost all of these take a height and a width argument afterwards, and I'll usually just do 0, 0. So dialog yes, no, and a title, and it says, you know, what say you? And I can arrow key or a tab key to choose different options. And, you know, I can click on something to choose it. And how do I know what the answer was? Well, I can look at my $? variable, and since I clicked on yes, $? came back as a 0. Now, if I click on no, $? comes back as a 1. So after doing this dialog command, all I have to do is check the value of $? I know whether the person said yes or no. And that's a typical way to get a response back from the user through a dialog. All right. If you want to display more information, you can say -- text box, and you can put in the name of a file. So I'll just pick on my bash RC, and there's the contents of my file. And I can scroll down with my down arrow key. I can scroll up with my up arrow. I can use page down and page up. I can use the home key to go to the beginning. And I can use the end key to go to the end. So if you want to display a bunch of information, right, you can do that. And let me see if I can guess this. Right, so I can change the exit label to something like continue, and then after they've read their message, they can hit that. And go on from there. All right, so I was going to talk about checklists and radio lists and things like that, but let's talk about getting information back from this thing. So let's do a dialog. -- calendar, title, height and width, and there's a calendar dialog. And you can click through and, you know, let's go with November 13th. That's when your assignment's due. And I'll just hit the enter key. And these commands that get something from the user, a selection or a text field or something like that, they return the selected item to an output channel. And so there's this kind of quirky way that we can capture the output from that. And it looks like this. So -- output _FD1. And so here's what I can do. I can say something like, you know, my date equals back quote, and I can put all of this stuff inside back quotes. And remember, what back quotes do is they say execute a command and then take the result of that command, and in this case set my date equal to that. So I'm going to run the dialog command. I'm going to ask it to create a calendar with a boring title of title with default dimensions for height and width. And this is going to say, take the output and send it to standard out so that I can capture it, in this case, inside back quotes. So my dialog, that's a dash. So my dialog still appears here, and I can go through and, let's do December 25th, and say OK. And now if I look at the value of my date, it's the month, day, month, and year that was selected. And if I do this, it'll just show me my current date, and so I can set my date equal to that, 3rd of November. All right. So this is the general mechanism we use for capturing the output of a dialog. And we can throw it into a variable. So instead of saying, you know, type in a date and then saying read my date, you can do this. Pops up a GUI. Person can interact with that. When they say OK, this variable will be equal to the date they selected. And that's the basic interaction mechanism. All right. So we'll go through more options for dialog tomorrow. But play around with it. Bring some questions. And we'll see you then. All right, thanks.